Captain Charles Conley and his crew are seafaring pirates who found a treasure map detailing the location of vast gold and silver. The map has 3 riddles that one crew member believes could be solved through trigonometry. The map reads, solve these problems to find coordinates 3. The coordinates will lead you to the treasure sought by thee. The first triangle is confirmed to be a right triangle with 2 lengths listed. A crew member suggests using the Pythagorean theorem to solve this triangle, but Captain Charles Conley is confused. The Pythagorean theorem states that a squared plus b squared equals c squared. You can plug in each side of the triangle into a and b, and this will give you the length of the third side. So 8 squared plus 6 squared equals c squared. When solved, you get 100 equals c squared. Then you can square root both sides to find out what the final side is, which the square root of 100 is 10.
Yes, Captain Charles Conley exclaims. We've solved the first triangle, and we know that the first coordinate is 10 degrees.
The next triangle is also a right triangle, but this time the angles are listed as 45 degrees and 90 degrees.
We must also use Pythagorean theorem for this one, it seems. But we were only given one side length, says Captain Charles Conley.
Wait, yells a crewmate. We can complete this problem through special right triangle rules.
Special, huh? Says Captain Charles Conley.
When a triangle has 2 45-degree angles and a 90-degree angle, you can use a special set of rules to quickly solve the third side, explains the crewmate.
Interesting. Explain how that would help us with this triangle, says Captain Charles Conley.
Any triangle with these sets of angles follow the same rules. These rules state that both short sides are the same length and the hypotenuse being the same length times the square root of 2. So for this triangle, the 2 missing lengths are 4 as the hypotenuse length is 4 square root 2.
Okay, I understand. But what is a hypotenuse, says Captain Charles Conley.
A hypotenuse is the side of the triangle across from the right angle, explains the crewmate.
Ah, I understand. But what a weird name, explains Captain Charles Conley. Okay, so we have 10 and 4. Let's try and solve the third triangle.
This triangle shows one side and one angle measurement.
Hold on, this one's angles are not 45, 45, 90, and we were only given one side. How are we supposed to complete this triangle?
It must be SOHCAHTOA, a crewmate exclaims.
SOHCAHTOA, says Captain Charles Conley.
SOHCAHTOA is a way to remember the 3 trigonomic functions sine, cosine, and tangent, explains the crewmate.
Okay, but how is that going to help us with this triangle? Says Charles Conley.
Each letter of SOHCAHTOA stands for something. For example, SO stands for sine, opposite, hypotenuse. This means you can solve an angle with sine if you are given the hypotenuse and opposite sides of the triangle. So for this problem, you would write it out like this. Sine, then the angle measurement, then the opposite side length, which we don't know, so we will use x, over the hypotenuse, which we do know, so we will write its length, 15, on the bottom. This means to isolate x, we have to multiply sine 56 by 15. Then just type that number into a calculator and you get x, explains the crewmate.
Okay, one question. What's a calculator, says Captain Charles Conley. It looks like we're going to have to do a lot of complex math, since we don't have one.
5 hours later, after some complex calculation, which can now be done with a calculator, Charles Conley found that the answer was 12.4.
Wow, that took forever. But now we finally have all the coordinates. X equals 12, then y equals 4, and z equals 12.4, says Captain Charles Conley.
Captain Charles Conley and his crew followed the coordinates where they found a chest, but all it had was a piece of paper inside. It read, one more triangle and I'll reveal where my treasure is. The triangle had 2 sides listed, but no angles.
Another triangle? What is it with this kind of triangle, said Captain Charles Conley. Well, none of the rules I've learned so far could help with this triangle. Anybody got any ideas?
Well, this might take forever again, but this triangle is also solvable by SOHCAHTOA, said a crewmate.
How? We don't have any angles, said Captain Charles Conley.
Well, another way to do SOHCAHTOA is to assign the angle measurement to x. So for this triangle, we could use tangent, as we have the opposite and adjacent side lengths. Then we set it up where it says tan, then the angle measurement we don't have, so x, equals the opposite side 5 over the adjacent side 10, explained the crewmate.
Okay, now what? Said Captain Charles Conley.
We can use a new function called arctan, or tan to the -1 power. With this function, we can now switch sides and make the equation arctan, or tan to the -1 power, of 5 over 10 equals x. 5 more hours of complex calculations later.
Wow, that took forever. They should really make something that can compute functions without doing so many complex calculations. Okay, so we got our answer 26.5. Now what? Said Captain Charles Conley.
Boss, read the back of the note, uttered her crewmate. The back of the note read, "We already found the treasure. What type of idiot would buy a used treasure map?"
What? I knew the guy who sold me this was sketchy. Well, at least we learned some math today, laughed Captain Charles Conley.
The end. Created by Marco Peterson and Carter Baston.